So Jeff and I, as Rob had indicated, came upon some of this discussion and really started talking about when do we talk about this publicly. It has been approximately 2 years and we finally came to a point with the escalation of things happening overseas and just the natural progression of where we're seeing some attacks happening in other sectors and industries that we figured we should talk about some important topics. So some of the things we are talking about, these are not vulnerabilities. These are not exploits. These are features. These are capabilities in these assets. And in many cases, they are what is being talked about from the tops of the hills of we need secure by design. We need capabilities to authenticate. We need capabilities to encrypt. We need capabilities in these devices and applications and servers. That is awesome. And we should be asking for them all just like the IT industry did. But we shouldn't think that the adversaries won't misuse them against us. Meaning we go ask for all these security features and then they can be turned on by someone else. And we can get locked out of all of our equipment and gear and they can be attack vectors 100%. So secure by design, but we are going to talk through how those things can absolutely screw you. A couple of other things. So as we talked about this discussion, we would love to show you targeting and positioning and getting a foothold into an environment, working our way down. And Jeff thought that's what we were doing. So he created about 69 slides. And we had about 6 demo elements. We have 31 minutes. So what we are going to do is a 1-hour webinar outside of this conference. Cameras, nice setup, everything to capture what we're trying to show. And then we will have all the different build up, how you get a position, a story behind the type of environment being impacted. We will show a number of different types of attacks and how these things can be misused. And then we will walk through the detections and the defenses. We don't have time to do all that here. So we are going to go straight into what you should think about, how those things can be misused, and then show some attacks on stage. This is not being live streamed. This is being captured here. We will turn it into a larger webinar as well. But that's where it got its don't say a peep discussion. We've already introduced ourselves. Yeah. You know me well. Eric Bassel introduction, Rob Emily introduction. They have introduced both of themselves. Jason will be playing the role of the attacker, so he's not going to be very talkative. As attackers usually aren't. Like, hey, here's what I'm thinking of doing. Do you see this? So you'll be hearing from Jeff and myself where we're playing the asset owner, operator, system integrator, and we'll bounce back and forth between system integration system, engineering workstation, and attacker station, and some camera feeds where you can see the peeps as they go through a distressful situation. So we're going to talk a little bit about ransomware. And when you hear people talk about ransomware and ICS or ransomware and OT, and you see statistics of, hey, it's impacting manufacturing at the greatest levels in critical manufacturing, and you see even organizations that do work specifically in the industrial control system space, talking about some of the areas where they're seeing this from a manufacturing subsector. The one piece that we are wanting to make you think and take a step back, when you hear ransomware, let's talk about those things in different areas. So we'll start with number one, kind of in the IT environment. So that first area where it is impacting the corporate business enterprise networks is the ransomware cases and the ransomware as a service that you're seeing everywhere. That is not what we're talking about. That is a problem for the IT infrastructure who has very, very difficult and challenging jobs, meaning their jobs would be very easy and very effective if there was no people. If there was no people coming in and using the systems and applications and doing their bowling scores and sending emails out and doing a whole bunch of other things and using applications in ways they were never intended, using company resources in ways they were never intended. Pandemic comes and everybody's working from home with split tunneling and kids networks are joined into the company networks. Their jobs are very, very difficult. Battling ransomware is a very, very challenging thing and is going to continue to grow without a doubt. But as you start to look at the other side of the company and we move into number 2 on here, the IT and OT adjacent systems. So think Maersk, think Colonial Pipeline, and start thinking about the systems that we don't do a great job of categorizing. Even here at an ICS summit, we often talk about IT and OT. That word in between is representative of a whole bunch of systems that aren't being categorized on either end or protected or supported appropriately. If it is business critical, I would advise you to start treating it as critical as your OT environment, your manufacturing execution systems, your ERP systems, your recipe systems, your quality systems. Start treating them in the way acknowledging and understanding the impact, if they were unavailable, that they would have on operations. And if that's true, then treat them like your operations assets. We may need to come up with a new term, business critical or operations critical. Right now, they're the things that are in between IT and OT, and they absolutely impact OT. Ransomware in that environment, often connections from corporate business, will bleed their way into that space and will have operational impacts directly. Number 3, the things that matter to operations. So even if the operational assets are not impacted, in many cases, the files they use for operator guides and procedures and emergency response sit in corporate business networks where those things could be made unavailable. Many times, some of the things you would need if there was a operational impact, your project files, data sets, that stuff is stored off in backup sets out in corporate. If that is encrypted or ransomed, that will inhibit your ability to recover operations. Those data sets and where they sit matter. Now we'll move over to this other side. Number 4, the OT, traditional IT-based endpoints. When you hear IT and OT are converging, we converged 20 years ago from a Dell server, IBM server, traditional Windows, traditional Sun Solaris, Red Hat, Linux, Cisco gear, and Terrasys, Juniper. We are using a lot of those same assets. And where you are running operator workstations on Windows-based or Unix-based systems, and you're running engineering workstations, you're running data servers, you're running historians, you're running display servers. In many cases, they are on traditional IT-based operating systems that can very easily, due to poor architectures, ransomware can spread and impact. So understand what your recovery capabilities are, what you will need to do to restore from those. Moving into the OT applications, this is a place that is not getting a lot of discussion. So as you're starting to look at the specific engineering applications, many of them have moved into a model with security features enabled. Launching an engineering application set in tool, in some cases will require authentication. We've asked for it, we've got it. In some cases could require multi-factor authentication. We asked for it, we've got it. You can't get into those tools without it, secure by design. Most people haven't turned it on. If an adversary got in your environment and turned it on, how would you recover your access to those tools? So looking across some of those engineering applications and the configurations of your field devices and the programming software and the individual components of how do you manage your environment, we are asking for more security capabilities. And we're getting them, but in many cases, we are not enabling them, but they're there to be enabled. Number 6, this is going deeper and deeper in, obviously, and moving into the OT function and control elements. As you start to get into some of those applications and tools, now you can start to see the ladder logic, and you can start to see the scaling and the configuration parameters and the process variables. And you can start to directly manipulate, you can start to directly program. There are feature capabilities that, again, were asked for from a security perspective for a lot of good reasons. These aren't vulnerabilities. These are things that have been asked for. If Jeff and I had been working at a Coke plant or some process environment, and we had the engineering know-how to do something that was special, that was a unique recipe or a unique capability that we could then automate a mechanical system, and we wrote the logic for it. We have the option to do something called source code protect. And we can take that entire subroutine or program set within the larger logic, and we can lock that element so that the asset owner and operator can't see how we did it. That is a feature that is not often used, but again, we've asked for it and we got it. So you could recover your logic, you could gain access back into your PLC, you could recommission, you could reconstitute, and then go in to look at your logic and find you can't see it, because someone locked you out of the actual logic program element. These are the things that then when you try to reconstitute that plant and bring it back up from an integrity perspective, you may find yourself in a position where you need to re-engineer and rebuild so that you can run safely. Number 5 and number 6 is really where we're going to spend our time. Numbers 1, 2, 3, and 4, we feel a whole bunch of people understand, maybe they're not prepared for, but they get it. As we get into number 5 and 6, I really want to highlight how these features that we are all clamoring for and not using could absolutely be used against us. So as we move through this quickly, I'm going to just show a couple of things from a data set perspective. We obviously do not have time to cover all these things on this slide. If you look at the static configuration, some of the things you will need to do to zero or home a machine or a robotic control, the recipe, the set points, the scaling factors, the is it Fahrenheit, is it Celsius, a lot of different variables could be manipulated directly, a number of different process variables, and sort of your batch or process data and where that is and how it's used. If you are blind to it, that could absolutely make it a very, very bad day. Thinking of how you would recover those and where that recovery element is also something super important to pay attention to. Again, we are highlighting things that could have been much worse in attacks that we've seen. Looking towards the computer systems, again, we've talked about, while we haven't seen ransomware moving to step 4 in that list that I showed, adversaries have been close enough that it could have happened by accident. And that's definitely where you get into a fog of war. So you think of the events that happened in Colonial. Back when they happened in Colonial, it was kind of an, aw shucks, this stinks, everybody's filling up bags of gasoline. It's not awesome, but it was just crimeware. It's just people after money. Now that the war has happened, what if that same attack happened tomorrow? Sourced from potentially an adversary nation? Or was it just crimeware, aw shucks, don't sweat it, pay the $4 million? Or was it nation state to nation state attack that could result in a escalation? So as you continue to look at these things, accidents could cause geopolitical events. Traditional ransomware that is in the IT and OT that bleeds in and starts to impact systems that are Windows or Red Hat or Solaris that are running and could also be subject to the same attack, intentionally or unintentionally. Do you have the ability to recover not just the system, but the applications plus the configuration and your license files and other things? As we move into a method of thinking about this, I'm going to speed us up a little bit. There are some pieces that we are showing here that we will cover a little bit more in depth in the webinar, but thinking of the level of difficulty from an attack, from data manipulation, code replacement, data encryption, all the way up to firmware, and then where those different things exist throughout your environment. And there's a lot of pieces in between here that has to do with architecture and detection and defense capabilities, but the actual doing of it, as you look through some of these environments, having access is the vulnerability. These are trusting systems. They will do what they're told to do. If you are on the engineering workstation, by design, it's meant to be able to connect and do a number of things. If you purchased and you have a number of security features, they are there to be configured and turned on. We are going to go through a couple of those things now in a demo as we walk through some of the technical controls that could be in place. Specifically on, we'll talk about one vendor, but many vendors have this capability. If you think of Active Directory or LDAP or a directory model, tools, companies like Rockwell have tools like Factory Talk Admin, and you can start to configure which engineering workstations can talk to which devices and which devices can talk to which devices in the field. You can enable an entire authentication and access model at the industrial control system level, working with a number of your vendors. And if you did that, you would be adding tremendous amounts of security. If we just ask for it and don't turn it on, it's there to be used in other ways. As we start to consider how that could be used, you could absolutely lock yourself out of a controller. And we are going to walk through some of that as we go through a demo here quickly. Some of the things on stage that you see, we have a programmable logic controller, a panel view operator HMI, we have a static switch, and we have some remote IO. Plus, we have ovens that these gentlemen have configured to cycle on and off based on a thermocouple temperature control. So they are operating at a safe temperature for the Peeps. And they have been operating there for some time. So if this was incubation or food and beverage, the Peeps are happy. So with that, we will move to a demo and I will switch to a different screen.
Actually, go back to that
Okay.
screen. Yep. All right. So I wanted to set the stage here just a little bit and say, you ever watch a movie that says this is based on a true story? This is based on a true story. So this case was holding our food supply ransom. And someone wrote, here's a possibility for how to do it. And so we talked about it and said, hey, is it going to be okay to at Sands to show Peeps, because there was an example of a grow house of chickens growing up and that being held ransom to interrupt the supply chain of food, right? Protein comes, or chicken is a good source of cheap protein. So a fellow from Microsoft wrote, hey, here's a scenario in which you could manipulate the environmentals of this to affect this grow house and actually then affect our food supply. And so that's what we did here. And in grow houses and other places, we find embedded systems like programmable controllers. You have HMIs that you'd view the process and enter the process set points. And that's kind of what's up here. So, yep. So we're going to work through this scenario. Jason and I are going to act like before he turns into evil Jason, he is going to be plant guy Jason. And so we're going to say, Jason, what is the problem that you're actually seeing right now?
Yeah, so at this point in time, we can see our peeps are fine. However, we're getting some weird activity in relation to the operation of the equipment. So as a plant engineer or as a controls automation guy, I'd like to go online with the controller, right? So as you can see, our desktop's not locked out, right? We have full access to that. So typical operation somebody will go through is they'll open up the application, right? They'll go and look for the program, open up the program. None of this is really profound. However, at this point, it goes to load the program, and something that we've never seen, we don't normally have to deal with, and I'm speaking from a experience standpoint of them using this system. It's already been commissioned. They get a pop-up saying you need to log into the application. So I've not seen this before. That's kind of odd, but okay. So I'm going to log back in with the same username password, which is engineer, because, and well, that doesn't work. So, okay, that's bizarre. Well, let's try admin, whatever password it is, and that doesn't work as well. So next step, specifically with this software is, well, let's go into the Factory Talk administration console. Again, asking to log in. We try to log in, and of course, it doesn't like it. So now at this point, we're in a predicament. We are unable to log into the system. We have this engineer workstation that's not functioning for us. However, luckily we do have, because we've decided to store our project files off of this box into a file server. So typically we're going to have the OEM, and luckily for us, our OEM is nearby, so we can call them in to help support this situation, because at this point, equipment's running, still running okay, but we'd like to go in and figure out what's going on. So I call up my buddy Jeff and say, hey man, can you come in and bring your laptop and try to get it online, figure out what's going on with this thing?
Yeah, so the first question as a system integrator, which I have done for many years, is I say, look, we had a site acceptance test. Have you changed the logic, Jason?
Yeah, we did change the logic. We did some tweaks. So
okay, which is a very real situation. A lot of times the end customer wants to have the ability to change things, override sensors and do stuff. So this isn't unusual yet. So what we're going to try to do is restore access to the PLC controller. We want to get access to the PLC software that is now password protected, but he can't get to that PLC project file. So he sends me the PLC project file. And what he would do is he would get his corporate security people to start investigating, why is there now security? Have you done something where you've disabled maybe single sign-on or something? Why is he getting a prompt, and why is he locked out of his account? So he's contacted me, he's given me the copy. So what I am going to do is go back here.
I will point out one element. The Factory Talk admin had not been configured at this organization for security purposes. They didn't set a password on this. They tried to log into the application and it was password protected. They can't take a backup copy of a project file and launch it from their tool set. Their licensing it is now locked. So they had to provide the project file to someone else, meaning you need to have a support agreement with your vendors or your system integrators who can be a partner in this fight with you.
Yep. So I am now in my own tool. I am an admin and I'm now going to open their project file. So just as a FYI is I could have locked this controller. So I can put a security descriptor inside the controller and have it actually reject my connection. And so the adversary right now hasn't been smart enough to do that. That's me and Jason. Tim would have been smarter about it. But so I'm going to type in, let's see here. So because I've configured my directory, basically my security authority. And the way this works is companies will have a set of products and they'll decide what security actions you should be able to do with that. And they'll authenticate normally against an Active Directory, but the authentication of or the authorization, what you're allowed to do is normally a product policy. So I come in here, I've got Jason's file. I can look at ladder logic. So I'm doing good so far, but I need to get down here to the oven temperature. And I notice these look different now. So I try to open them up and I can't do it. And so what the adversary has done is it's not something that I know, my password, but it's something that I have to have. So there's a token that I have to have that is associated with this particular file. So I call up Jason. I said, dude, the Red Chicken faction, whoever they were, they have locked you out of that particular routine. So go ahead and you already launched.
Mm-hmm.
So, yeah.
Do you want to go back to him?
Yeah. So I'm going to go back to the slides. So we're going to say, where are we at?
Well, let's pop to the Peeps.
What's that? So I am now currently locked out of the system integrator project file. I can't actually do anything about it. So I think this is just to show and remind our status is not awesome. Right now, the chickens, I think we can go to the
Let's
camera.
switch to the chickens.
Switch it, see how the chickens are doing. So the chickens are now getting hot. Their eyeballs have actually melted off.
They've lost their eyeballs.
They've lost their eyeballs and they're starting to get to be chunky chickens. So things are actually going very bad here. So at this point, we're not quite sure what to do because we've lost control. And yeah, this is the current status actually.
Leave on chickens.
What's that?
Just leave on.
Leave it on the chickens. That sounds good. So far we can get a project file open, but what this is going to take to actually recover this is to pull out the processor and clear it. So I'll have physical access to it. Number two is now I'm going to have to create the oven temperature routines, which isn't necessarily an easy thing because whoever wrote this may not be in the same industry or with the same vendor. And we can see our chickens are actually starting to turn brown. They're actually starting to burn. So our unknowns right now is we have no idea what maximum temperature this is going to reach. And we have no idea how fat they're going to get either. So they're starting to blow up. We also don't know whether or not it's a tuning problem. So in many cases, we drop these factories into the middle of rural areas, and we haven't taught our operators how to actually tune them, go online and do anything with it. So we have so many unknowns. We've got so many unknown variables. We really don't know what to do. So I'm going to go to the conclusions. So
Hey, can we take 1 second and say, so the attack that we talked about in the 6 elements. So number 5, attacking and locking you out using security by design features from your actual engineering applications. So someone else configured those and locked you out. Element 6, going into those logic files and using the secure by design source code protection, locking different elements and pieces so they can't be modified or changed. You didn't do it, an adversary did it. So now from an actual operations perspective, you are operating in a model where you can't see or access your files. You need to get a third party involved. You need contracting to do it. You don't know if it's a process failure or something else is happening. You can tell things aren't going the way they should be for the peeps. So you're trying to find out what is happening. If you extend this to any other industry, from vaccine development to pharmaceutical development to a continuous process or a generating station, this is all very, very bad. If you can't see the actual logic files, you can't access the systems and devices and controllers in your field. And when an integrator says, we have access to it, but you must have source code protected it, we can't read it. And you say, we didn't source code protect it either. After all of that has happened, the access you needed to do those things, to turn on the security features, Jason has simply launched an attack that is directly impacting. So if you could talk about that a little bit before we get into the conclusions.
Can you turn the camera on?
Yeah,
for sure.
So yeah, I mean, what we've done is obviously we've locked them out of being able to have visibility. We've locked them out of being able to access the edge of your workstation. And then we've essentially set the set point for the environment to just go, to a high amount. I think a key takeaway, obviously, 55-cent peeps, not a big deal, right? But the point being is this looks like an operational problem with weird software situation, which can kind of come up, especially with some of this advanced security I've dealt with in the past, where people don't fully understand exactly how it works, so they can get caught up into trying to figure out why is this software not turning on the way it's supposed to. Also the fact that it's kind of odd that it's like, wait a minute, I can open the file, but I can't see everything. Maybe I don't know what source protect is. Maybe it's just my software install is broken, whatever. So at this point, when you're thinking about 55-cent peeps, clearly we could just shut it off, but when you're talking about, something that's operating $1 million worth of product, that kind of decision, that do we just dump $1 million down the drain, or do we try to keep fighting this and figure out what's going on? Because what started this was we just had some weird things we wanted to look at, right? So the decision process is a complex one based on how operations views it, based on knowing that we had this attack happening. They didn't know at the time.
I have one.
So you
One
can tell our
comment.
peeps are not doing so
No,
great.
actually, you can turn that back.
You want the
on.
peeps back?
Just one more
Yeah.
peep thing.
So
What's
our peeps are starting to smoke, so maybe we should.
Yeah, we'll turn- so one thing within that's important, actually in the poultry industry, they do this a lot. There are manual controls. Yeah, they're actually starting to smoke.
So we gotta go manual mode.
So here's manual mode. Listen. Right on. So a lot of times having manual mode, yeah, it's starting to smoke. Sorry about that, hotel staff. So we'll do you are now all members of the Fellowship of the Peeps. So we'll do the conclusion now.
Conclusions.
The
I got you. I got you.
Thank you.
Yep.
Yeah.
Yeah, we'll get them.
I'll tell you what, you
You
do
go
the
ahead.
conclusions,
No,
I'll take
no,
them out.
You do the conclusions.
Oh,
I'll
okay,
take 'em.
there you go. All right, so we believe that the ransomware, a natural, that's so awesome. That's going on my resume somehow. So one thing that we believe is that ransomware, as it continues to move through manufacturing, a natural progression is going to be things like this. So this is very easy to do, actually. It's not hard to set up a security system, lock controllers and do that stuff. Most of the security systems do have those features built in. I wasn't kidding. The critical industries will have manual controls, and we have been on situational training exercises where we cause, kind of the fog of war, and things happen. They say, I think we got it under control, and we launch another attack. And eventually we get around to, hey, there's some manual controls over here. So look for manual controls. If you don't have them, have some way to take the cyber elements out of these. There's a whole science about mechanical systems and protecting them with actual physical assets like that. Have backups ready. So again, on the webinar, I'm going to talk about the 5 kinds of data we Jason and I talked about it last year, but it really needs to sink in how you're going to do data recovery, because getting a program is one thing, getting that reconstituted, but the data in which it runs is, again, there's about 5 different kinds, and you need to have SOPs to be able to reconstitute that data. And that's pretty much it. I don't know if there's any questions.
Yeah, there's one thing I just want to add, and that's, when you're thinking of deploying security controls, but also even just advanced infrastructure, where you're relying a lot more on like network access control and just other things that help kind of the flexibility that we kind of need in infrastructure today versus maybe the past. This even goes with like VMware and clustering and those type of things, right? It goes hand in hand. We talk about, more reason to have a manual control or an alternative out of band way of monitoring what's happening to be able to make decisions. But it also means that in the technology, you have to think, well, do I need to have maybe something that's not using that same advanced technology that might be separate or separately networked or isolated or protected in a means so that I can still have the visibility I need in the environment, right? So, and also recognize that that also opens up another avenue and another vector that could be complicated. So none of this is easy, but the point is that it's not as simple as just checking a box and saying, oh, this system now has security, and we just turn it on, right?